We are finding the limit of a function as it approaches positive or negative infinity, and we're also finding the limit of a piecewise function. Okay. We've already done both of these, but when we did them earlier, we had the calculator in our hand. So now we want to be able to do it without the calculator in our hand. Okay. So find the limit of a function as it approaches positive or negative infinity. So we've got 3 examples on that. I'm going to go ahead and put all 3 on the board right now. That way we can cover each one of them. Russian. All right, so these are 3 different scenarios when we are finding the limit of a function as it approaches positive or negative infinity. Now, the other day when we were doing this, we had our calculator in our hand, and what did we figure out was going to be our limit as we approach negative or positive infinity?
Asymptotes.
What type of asymptote?
Horizontal.
Horizontal. The horizontal asymptote is going to be my limit as I'm approaching positive or negative infinity. So, on the first one, x to the 6 plus 12x over 3x to the 6 plus 2x squared plus 11x. What is my horizontal asymptote going to be? 1/3 is correct. Why, Rachel?
Because the exponent on the biggest x value are the same, so
So the largest exponent of the numerator and the denominator are the same. When that happens, I just take the coefficients. So that gives me 1/3. So we will verify that graphically. So I go to my graph. As I said, I go to my graph. There we go. Alright, so here it is. Notice, as I go out to the right towards infinity, what are we leveling off at? 1/3. As you can see, 1/3 is about right there, and that's where we're leveling off at. Alright, the second one. 2x squared plus 7x minus 17 over 3x to the 5th plus 4x squared plus 2. I want the limit as we approach infinity on that one. What's that one going to be?
Can it be 2/3?
This one is 0. Lauren, why is it 0?
Because since the exponents are different, you just look at the coefficients, and since the coefficient is smaller than the bottom one, it's 0. No.
Alright, you had a mixture of stuff in there.
Just kidding.
Alright, I need to look at the highest exponent first. The highest exponent of the numerator is 2, the highest exponent of the denominator is 5. Whenever the denominator exponent is larger, my horizontal asymptote is 0. So if I go to the graph on that one, here's the graph of this one. Notice as I go to the right, as I go to the left, we're both leveling off at 0. So that verifies what we found. Alright, then the third situation, as the limit approaches negative infinity of negative 3x squared plus 7 over 5x plus 1. And this situation is where the exponent in the numerator is larger. And what does that tell me? There is not a horizontal asymptote, which means the limit does not exist. Okay, and when we are approaching something, well, what if it doesn't exist, what's my graph going to do? As I go out to infinity, if it's not leveling off at something, what is it going to do? It's going to go up or it's going to go down. Okay, so in this case, when we say D and E, we also want to say where it's headed towards. So, any ideas on where this one is headed and why?
Infinity.
Alright, to figure it out, I look at the largest exponent and the largest exponent of the bottom. When I plug something into the one in the numerator, or in this case, since it's going to negative infinity, I want to think about a negative number. If I plug a negative number into the numerator, is it ended up being negative or positive? Negative. Because if I square it, it becomes positive, but then I have to multiply it by -3, so that means my numerator is going to be negative. If I plug negative infinity into the bottom, what would it make it? Negative. So if I have a negative over a negative, that means it gives me a positive, and if I get a positive, that means I'm headed towards positive infinity. So let me recap what I did right there. Since I'm going to negative infinity, I plug a negative value into my largest exponent of the numerator and determine whether or not it's positive or negative. When I do that, it becomes negative. I also do the same thing to the bottom. It becomes negative. The combination of those two is positive. That's why we say it heads towards infinity.
Why is on the bottom negative or positive or whatever? Do the bottom bit again.
Negative.
Why?
So since I'm going to negative infinity, I want to plug in a negative value.
Right.
If I plug a negative value into that, would it be positive or negative?
It'd be negative.
It would be negative. So that means the bottom is negative. When I plug a negative value into that in the numerator, it is also negative. The combination of those two is positive, so that's why it's going to positive.
Oh yeah, that's because it's squared first.
It's squared, which makes it positive, then times -3 makes it negative.
Okay.
So if I go to the graph of that, as I head out to the left, what should my graph be doing? What did we just figure out?
It should be going up.
It should be going up. So as I head out to the left, what's my graph doing? Going up. Now, let's say I was going to positive infinity in this case. So I plug in a positive in the numerator, what would it be? It would still be negative. But if I plug in a positive into the denominator, it would be positive. And the combination of those two is negative. So as I go out to the right, what should my graph end up doing? It should be going down. So as you see, as we go out to the right, my graph is going down. So those are the three different situations. If you're approaching infinity, I'm interested in what? To find the limit as you're approaching infinity or negative infinity, what are we interested in? The horizontal asymptote. If my exponents are the same, I take the coefficients. If the bottom exponent is larger, my horizontal asymptote is 0. If the exponent in the numerator is larger, that means it's D and E, and then I figure out, is it going to positive infinity or negative infinity? So that is finding the limit of a function as it approaches positive and negative infinity. Any questions on that? What do you say, Bob? Are you awake?
No.
You need some on my Mountain Dew?
That makes your teeth rot.
Sorry.
Yeah.
So there's a lot of things that make your teeth rot.
Thank you.
Seriously, like Coca-Cola.
Or cocaine,
Just trying to help out your health.
Anything. Right? Pretty much anything you eat, you're gonna rot eventually.
But all these baby guys still get people pregnant.
How did we end up on getting somebody pregnant?
What?
They said God do make you infertile.
Oh yeah.
Makes you internal.
Infertile.
I have no problem.
Alright, back to
Now we're finding the limit of a piecewise function. So here's our piecewise function, because it's made up of pieces. I'm interested in the limit as it approaches 0. In order to find the limit, what must happen? In general, not necessarily in this problem. What has to happen? If the limit exists, what has to happen?
X has to be.
Same number.
As I come into an x value from the left and from the right, I have to be going to the same value. Okay? Notice, where is it I'm headed in this case?
0.
0. And notice, where does this piecewise function split? It splits at 0. What I mean by split is, what is my x value where it changes from one function to the other? Okay?
0.
So most of the time, when they ask you to find the limit of a piecewise function, they're going to ask you, what's the limit where it splits? Okay, notice we're going to 0. That's where this function splits. So I have to consider the limit from the left and the limit from the right. Because in order for the limit to exist, what has to be true about those two limits? They have to be the same. Those two limits must be the same. So I need to check both limits. So, if I want the limit from the left, which one of these pieces do I want to plug into? The top or the bottom, and why?
You want
The
the
top.
top, because
Why?
x is less than or equal to 0.
Because we want, it says x is less than or equal to 0. The left side of 0 is less than 0. So that's where I want to plug in. So I plug 0 in, what value do I get? I get 2. Okay. Then I want the limit as we approach 0 from the right. So which one do I need to plug in here? I need to plug into the bottom, because on the right side of 0, we're talking about numbers that are bigger than 0. That's where x greater than 0 falls in. So I plug in 0 to this, I also get 2. Since these two values are the same, that means that this limit, that limit is 2. So I check the left, I check the right. If I got the same value, I have a limit. Now, sometimes, just to make sure you're paying attention, they might say, what's my limit as I approach 3? Okay, what's my limit as I approach 3? What would I do then? Very good. I would plug 3 into the function that is greater than 0, because 3 is greater than 0. So I plug 3 in, and I would get 2 minus 9, which means it would give me a limit of -7. So I really only have to check the left and the right if I'm going where? Wherever it splits. In this case, 0. It's not always going to be 0. So I have to check the left and the right if I'm going to where my function splits. If my function isn't splitting, then I just plug it in to the correct function. Yes.
But how do you know at 3 is approaching the same from the left and the right?
Because what's the number 1 rule in finding a limit?
It has to approach the same.
Number 1 rule in finding a limit.
Plug it in.
Plug it in. And if I get a number,
It is your one.
that's my solution. So in this case, I'm going to plug 3 in. I plug 3 in, I got a number, no issue, so that's got to be my limit.
See, that's not something that's
All right, one more. All right, limit as x approaches 2 of x minus 2 squared plus 1 when x is less than or equal to 2, and x minus 6 when x is greater than 2. So do I need to check from the left and right on this one? Yes, because I'm going to the place where my function splits. So what would my limit be from the left? Which one do I plug into? The top one. So I plug into the top one. If I plug in 2, 2 minus 2 is 0. 0 plus 1 gives me 1. Okay, which one do I plug in for the right? The bottom, I plug 2 in. I get 2 minus 6, which is -4. So what does that tell me? It does not exist. My limit does not exist. It can't be headed someplace if I'm headed to 2 different places.
Oh.
We only care about where it's headed. When it's
going to infinity.
when it's going to when we're going to infinity or negative infinity, or when we're approaching an asymptote. Very good. Those are the only 2 finds I need to determine where it's headed.
Okay.
All right, now this is a good spot to do a little bit of review, and let's go ahead and graph this piecewise function. So, what type of function is my top function? What is it? What is it? What's the general form of that top function?
Parabola?
Parabola. How do I know it's a parabola, Kathleen?
It's squared.
Because I have a square. If I see a square, that tells me I'm dealing with a parabola. Okay? So, this is the one that has the equal to part on it. So that means at 2, whatever value this is, I can have a closed circle. On the other one, whatever my value is at 2, what has to happen? Has to have an open circle. So, I already know at 2, I'm at the y value of 1, because we figured that out. Okay, now which way is this parabola going to go? Is it going to go to the right, or the left, or the right? And why?
Left.
Where?
It's going to the left
Go to the left. Why is it going to the left?
because x is less than or
Very good. I use this piece when x is less than or equal to 2, which means the parabola graph has to be on the left side. So that means I want to plug in a couple more points on the left side. So let's plug in 1. 1 minus 2 is negative 1. Negative 1 squared is 1. 1 plus 1 gives me 2. So I've got that. And let's go ahead and plug in 0. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 plus 1 is 5. 3, 4, 5. So my parabola looks like that. On the other piece, what do I know this is? What is it? Speak up. It's not a trick question. It's a line. Okay? We already figured out that our point at 2 is negative 4. So I know, and on this one, it's got to have an open circle. Which way is this one going to go? To the left or to the right?
to the right.
It's going to the right because we're dealing with x greater than 2. What do I know about this line? It has a slope of 1. My slope is 1 right here. So that means if I go up 1 and over 1 and then draw it, that's what we're dealing with. So from the left, we were headed towards 1. From the right, we were headed towards 4, just like we said. Okay, so that is finding the limit of a piecewise function. I have to check left and right when what's going on. When I'm approaching where it splits. If I'm approaching an x value that is not where it splits, all I have to do is plug into the correct piece, and that's going to be your limit. Okay, but if you're approaching where it splits, you got to check the left and the right. If it's the same value, you've got a limit. If it's not the same value, the limit does not exist. But
Will you always plug in the negative on the top one?
not necessarily. The negative, the left side is always going to be plugged in to where it's less than. The right side is always going to be plugged in where it's greater than. Okay? Most of the time, they'll probably write it this way, but it doesn't have to be written that way. You may get finished before we leave. If you do, go ahead and bring it to me. We'll get it checked off.